When multiple bonds, such as double or triple bonds, are to be evaluated by Cahn-Ingold-Prelog priority rules, they must be modified before analysis begins. Priority rules require the atom to be saturated. So, for an example, a carbon is attached to 4 atoms or units. Initially, this isn't the case with multiple bonds. So the bond is theoretically changed to a single bond with the addition of 1 or 2 single bonds to 1 or 2 ghost atoms of the multiple bond partner atom. So with a double bond, it is theoretically altered to a single bond, and the lost extra bond gives a single bond to a ghost atom double bond partner. So A now is attached through a single bond to ghost atom B, and B is attached via a single bond to ghost atom A. The ghost atom is not real, but just for the benefit of the priority calculation. The ghost atom is distinguished from a real atom by having brackets around the ghost atom. A triple bond is also theoretically altered to a single bond with the loss of 2 extra bonds. Thus, each of the triple bond atoms must have 2 single bonds to atoms of the triple bond atom's partner atom. So, A will now be attached through 2 single bonds to 2 ghost atoms of B, whilst B has 2 single bonds to 2 ghost atoms of A. Now we are ready for the Cahn-Ingold-Prelog calculation. But how do we treat a ghost atom in the analysis? A ghost atom is a unit rather than an atom, as it isn't real, but it has the same priority as the real non-ghost atom. However, this is true for that specific number of bonds from the origin. If a determination of stereochemistry can't be made at that distance from the origin, which it won't be able to be if the atom or ghost atom are equivalent, for example, carbon and ghost carbon, the analysis moves a further bond out. Now we aren't looking at the atom and the ghost atom, but what they are attached to away from the origin of stereochemistry. Because the real atom is attached to something else, but the ghost atom is not, then if we are just considering the atom and its equivalent ghost atom in isolation, the ghost atom's ultimate consequence once the next bond from the origin is viewed is to be a lower priority than the equivalent atom. That would make a ghost carbon higher in priority than hydrogen, but in isolation lower than oxygen, fluorine, or carbon, for example. A ghost oxygen would have a higher priority than hydrogen or carbon, but a lower priority than fluorine or oxygen. These observations for ghost carbon and oxygen are a generalization and not always true in every case. The rest of the molecule has to be systematically considered in conjunction with any ghost atoms. The pure rule is, for example, real and ghost carbon have the same priority, and real and ghost oxygen are the same priority where they are the same number of bonds from the origin of stereochemistry. The consequence of this methodology is that functional groups can be assessed with an ester as the higher priority, sequentially getting lower with carboxylic acid, amide, acetal, aldehyde, primary alcohol, nitrile, primary aldamine, terminal alkyne, 2-propene, sec-butyl, vinyl, and lower priority isopropyl. Let's focus more closely upon the lower 5 functional groups in that list and in detail see why they are in that priority order. To start, let's look at the ethinyl group. Here it is. And let's include the key ghost atoms. There. Now we need to identify the atoms or units, a specific number of bonds from the origin of stereochemistry. For this purpose, let's imagine that that is the R group. So 1 bond from R is a carbon atom. 2 bonds from R is a carbon and 2 ghost carbons. Recall, these all have the same priority. 3 bonds from R is 2 ghost carbons and 1 hydrogen. Next, let's consider the 2-propene group. Here it is with ghost atoms. Now, 1 bond from R is a carbon. Then 2 bonds from R is 2 carbons and 1 ghost carbon, all the same priority. Then 3 bonds, we find 1 ghost carbon and 5 hydrogens. How about sec-butyl? There are no multiple bonds, and this has been included to contrast with multiply bonded analogues and see the consequences of ghost atoms in the calculation where there is a multiple bond. So 1 bond from R is carbon, then 2 bonds from R is 2 carbons and 1 hydrogen. 3 bonds from R is found 1 carbon and 5 hydrogens. Note there are hydrogens 4 bonds from R on the upper carbon in green, but we don't need to go there as we can discriminate between all groups before that point. Next, the vinyl group. Let's remove the double bond and introduce the ghost atoms. 1 bond away from R is a carbon. 2 bonds away from R is a carbon, ghost carbon, and hydrogen. Whilst 3 bonds from R is 1 ghost carbon and 2 hydrogens. Lastly, the isopropyl group. Now that is similar to the sec-butyl in lacking multiple bonds, but it acts as a contrast with similar groups with multiple bonds. 1 bond from R is carbon. 2 bonds from R are 2 carbons and 1 hydrogen, with 3 bonds from R being 6 hydrogens. Now we will work down the table systematically comparing the priorities of each atom or unit for each group on the same horizontal line. With 1 bond from R, all groups have a carbon atom. No priority difference anywhere, so we can't discriminate and need to move 1 line down. Here we are, 2 bonds from R, and again, all atoms or units are carbons on this line. There's no priority difference, so moving on to the next line. Still 2 bonds from R. There are 2 ghost carbons and 3 carbons, but they are the same priority. So no difference, thus we move to the next line. Now we have 2 ghost carbons, 1 in ethynyl and 1 with 2-propene. But the rest are hydrogens. There is a priority difference. So the ethynyl and 2-propene groups must be either first or second priority, but we don't know which is which yet. Whilst sec-butyl, vinyl and isopropyl must be priorities 3rd, 4th and 5th. But again, we are at the moment not knowing which is which. We will keep going until each group can be given a discrete priority. Next line down represents atoms or units 3 bonds from R. And here, all groups are either carbon or ghost carbon of the same priority, except for the isopropyl group that has a hydrogen. That is a lower priority. From this, it can be concluded that the isopropyl group is the lowest 5th priority group. The next line down is all hydrogens except for the ethynyl. That is a ghost carbon. Thus, ethynyl is the highest first priority, and therefore 2-propene must be the second priority. To see the final distinction between sec-butyl and vinyl, we must go down one more line, and now sec-butyl has a hydrogen and vinyl has nothing. The hydrogen is a higher priority, so sec-butyl is the 3rd priority and the vinyl group the 4th priority, with a different priority for each group. We can stop. Let's see this with specific molecules. The chloro group in all these molecules is the highest priority, and the hydrogen facing back is the lowest priority. For all these stereogenic centers to be S, the group on the right must be a higher priority than the group on the left. If we compare sec-butyl and vinyl groups, the only difference is that the sec-butyl has a real carbon 2 bonds out, and vinyl has a ghost. Everything else is the same. Whilst carbon and ghost carbon are the same priority, if we follow those paths out 1 bond further, the real carbon of sec-butyl is attached to 3 hydrogens, but the ghost carbon of the vinyl group is attached to nothing. Thus, the sec-butyl has a higher priority. What is true for the atom and unit comparison, as we have previously described as being in isolation, here is also true for the whole group, as these are the only differences between the groups within 3 bonds from R.